Hey there, we're still in 7.2. So there's one more thing. In this section, it's a different method, slightly different. It's called the rejection region method. So we've been just focused on what's called the p-value method. Some scenarios, it's a little harder to find the p-value, so there's a way around that with this rejection region method. So, the first three steps, there's no difference. It's exactly the same as p-value. Where things change is step 4. Instead of finding a p-value, you find what's called a critical value, and then you use that to make your decision. Okay, so the critical value depends on the level of significance. So this is a good table to use if it's one of these main common levels of significance that always seem to pop up: 10%, 5%, 1%. Occasionally you'll run into a problem where it's like 3%, in which case you'll have to use StatCrunch for that. And I'll show you that right now. Or just in general, like, where are these critical values coming from? Okay, so if I were to draw that out, basically, like in this problem here, let's say it's a left-tailed test, and the alpha is 0.1. So that's this scenario right here. Okay, what we're finding is that z-score that's right in defining that critical value. So the negative 1.28 is this value right there on the number line on the x-axis. And where you find that is using technology. So I'll bring up StatCrunch and I can show you how that works. It's the normal calculator, right? All of this is z-scores, so it's that stat calculator normal. But now you're given the alpha. Alphas are going to go over here. So I put the 0.1 there. And if it's a left tail, I'd go less than, and then compute. And that's where that negative 1.28 comes from. Okay. So if it's a right tail, I'll do a greater than, and then put in the 0.1. And there's that positive 1.28. Okay. For a two-tail, one thing on this one that might be a way to do it is use the between. The between is going to give you the middle percentage. The alpha is actually on the ends. So I would do in here a 1 minus 0.1. The reason I'm doing the 1 minus, the alpha are these two tails, right? But what StatCrunch wants is the middle. So I have to trick StatCrunch to give me the right answer. So I'm putting in 90% as opposed to 10% basically. But it gives me those two values, and you can see on my notes that the two-tailed test when alpha is 0.1 is plus or minus 1.645. That's where those are coming from. Okay, so now you can get any critical value you want. Okay, so suppose it's a right-tailed test and your alpha is 3%. So for a right tail, I'm going to go greater than, and then over here, I'm just going to put in 0.03. And then my critical value would be 1.88. So typically you don't have to use this because you can just use that little table I gave you. You're only really going to have to use this if it's some obscure alpha, like in this case 3%. Okay, so let's go do some hypothesis testing. I'm going to go back to the handout. And we're going to do some problems that we've already done. but just with this new method. Okay, so basically what you're doing is finding that critical value, and then to make your decision, you're gonna compare the critical value to that z-score that you found in step 3. And on these, it's probably best to do a drawing. So I'll draw these out. They're called rejection regions when I draw them. They're little shaded regions. Like this right here would be a rejection region. But let's do it with an example. So let's go to this number 8. So I've already got it started because we've done this problem using the p-value method. So this is the HOHA. This is that fast food one with the 4.9. And the z-score we did back on the previous page, right here. Okay, so it's just that, oops, not the p-value, but the HOHA and the z. Steps 1, 2, 3, same. Okay. So step 4 is where it changes. Instead of finding that p-value, you're going to find a critical value. So here, alpha is 0.05, and it's a left-tailed test. So I go up here to 0.05 left. The critical value is negative 1.645. What I'm going to do with that is draw it out. So I'm going to draw a little distribution here and draw a little left tail. And the negative 1.645 is right on that shaded region there. Okay. Now the question is, this value, the z-score here, is that in the shaded region or not? So I'm going to plot that one as well, maybe with a different color, like red or something. So where would negative 1.29 lie? Well, it would be less than, actually greater than the negative 1.645. It would be something over here to the right of negative 1.645. So the z is not in the rejection region. Okay, so say that again. That z-score that we found is not in the rejection region. It's outside of the rejection region. This here says if the standardized test statistic, that's z, if z is in the rejection region, reject h sub 0. If it's not, fail to reject h sub 0. So this one's not in the rejection region. So this one is a fail to reject h sub 0. Okay. And then my final conclusion is the same that I got when I did this problem with the p-value method. How I come up with that conclusion again is HA is the claim, and I just failed to reject h sub 0. Those two things together will lead me to that conclusion. You can look that up on these notes. The beginning of this note packet has that little table of conclusions. But the way I think about it, I can almost just not use that table anymore, because anytime it's failed to reject, it's going to be insufficient evidence. And anytime HA is the claim, it's going to be the word support. So this one is, there is insufficient evidence to support the claim. Okay. Let's try another one. Number 9, we've already got it started. So I'm jumping right into finding that critical value. So where's my alpha? 1%, and it's a two-tailed test. I go to that little table, 1%, two-tail, there it is, plus or minus 2.576. Draw it. This is a two-tailed test. And I'm putting that value, 2.576, negative 2.576 is there. positive 2.576 is there. Now my question is, this z-score here, where is it? Is it in that rejection region or not? I can do that with a different color. So 2.65, negative 2.65 would actually be in there, right? That would be my negative 2.65. So in this case, the z-score is in the rejection region. If it's in the rejection region, in that shaded area, reject H sub 0. Okay? To make your final conclusion, use the fact that you have the claim is HO and you rejected HO. So my final conclusion, if I reject HO, it's always sufficient. And if HO is the claim, I use the word reject. So my final conclusion, the full sentence would be, there is sufficient evidence to reject the claim. Okay, so that's the rejection region method, a little different. Notice you're not finding p-values there, you're finding critical values. But the solutions and the final answers would be the same. Okay, stop there. Hope all is well, and I'll talk to you soon.